Hey everyone, in today's video lecture we will be trying to understand how do chlorination work and how do we measure the amount of chlorine needed for the disinfection of the water. So let's suppose you are a medical officer or a medical student, whatever, and you are in a village setting where there is an outbreak in the village. So because of this there is like diarrheal outbreak. So everyone in the village is getting diarrhea for some reason, and as you inspect the area and investigate, so you found that these village people, they drink or they get the water from a source that is a well, and you see that the well is contaminated. Okay, it is not clean, it is contaminated. So now how do you help these villagers? Because you are in a village setting, you don't have any high end equipments or you cannot spend too much money, so you will need to do some kind of jugaad. And at this point in the village, people like us, we use chlorine is cheap, it is available. Okay, so that is nothing but the bleaching powder. The bleaching powder has chlorine. As we know that chlorine helps in disinfection of the water, but we need to know how much amount of chlorine is needed to disinfect this much amount of water. So that is what we will be trying to understand in today's video. Okay, so this is the village, just an imaginary scenario. In this village, let's suppose this is the well and this is the contaminated well, and our job is to make sure we make this well water good or disinfect. Now for that reason, we cannot just take bags and bags of chlorine and just put inside that. It doesn't work like that. Okay, there should be some measurements or calculation has to be done in order to know how much amount of chlorine is needed to disinfect this much amount of water. So for that there is this Horrocks method or Horrocks apparatus, in which there are certain things. Okay, like you will have a black cup, one black cup, then you will have two metal spoons, two droppers, seven stirrer, then there is starch iodine solution and one pipette. Okay, then there are six white cups. So you just remember one black cup, one black cup and six white cups, and these white cups are all 200 ml of volume. Okay, so we understood the apparatus. Now what are we doing with the apparatus? The first thing is making of the stock solution. What is stock solution? Now we will take the black cup and inside that we'll put the chlorine, okay, and some amount of water. So this will form a paste kind of thing. Then you will add more water inside that. Okay, until in the black cup there is a marking here. Okay, so until that mark you will fill the water. So that becomes the stock solution. Next what you will do is you will take the other 6 cups, and in that other 6 cup you will pour the well water, which is the dirty water which we need to disinfect. Okay, so that dirty water will be taken out and it will be filled until its volume 200 ml. Okay, we have filled it. Then what are we doing? Then we are taking this water, the stock solution that we had prepared earlier, we'll take that in a dropper or in a pipette, something in a pipette we'll take, and we'll put 1 ml here in the first cup. Okay, as you can see here, the cups are arranged in such a way like N1, N2, N3, N4, N5, N6. So there are 6 cups. In the first cup you will put 1 ml of that stock solution. In the second cup you will put 2 ml, third cup 3 ml, fourth 5 and 6. Okay, so as we go increasing the number, you will increase the number of mls. Okay, and then we come to this formula. So N into 2 gram equals to 455 liters. Now you will be confused, what is this formula, how is it coming? Now let me tell you. As you have seen, this is a metal spoon, and this metal spoon we are using to make this stock solution. So this metal spoon, when you take the scoop of chlorine or bleaching powder, this will have 2 grams of bleaching powder. So you are preparing 2 grams of stock solution. Like this stock solution contains 2 gram of bleaching powder. Okay, and inside the general estimation is that bleaching powder, let's suppose you are taking 100 grams of bleaching powder, out of that around 25 to 30% will be chlorine. We are not going into that detail because that will take again, the length of the video will increase. We don't require that much. We'll just finish it off as soon as, like, as easy as possible. Okay, so stock solution, inside that we have 2 gram of chlorine, which is coming from this spoon, metal spoon, which is whose volume, the capacity is 2 gram. Okay, so this is that 2 gram. Now what is N? And N also we understood ki N means, the N1 means first cup, N2 means second cup, which has 2 ml, this has 3 ml, this has 4 ml. Okay, so this N is nothing but the cup. Now what about 455 liters? How do we come to this value? Ki you are multiplying this number of cups times 2 gram and you are getting 455 liters. 2 gram we understood it is coming from the metal spoon which we use, which has the capacity to pour 2 grams. Now what about 455 liters? Okay, come here, I will tell you. So there is a standard assumption. It is assumed that to disinfect 1 liter of water, it requires almost 4.4 milligram of bleaching powder. Okay, now this 4.4 milligram, now it is not exact because see, it depends on how dirty is the water. If it is more dirty, like severe, then it requires more amount of bleaching powder. But we are trying to make some sense out of how this value is arrived. Okay, 455. So let's suppose 1 liter of water, the dirty water is required 4.4 milligram of bleaching powder. So for 2 gram of bleaching powder, how much amount of water it can disinfect? So 4.4 milligram, this is milligram, not gram. Okay, this is gram and this is milligram. So 1 gram is 1000 milligram. So 4.4 milligram is required for disinfection of the 1 liter. 2 gram will be how much? So you just multiply, cross multiply 2 by this value will give you 455 liters. So 2 gram of bleaching powder disinfects 455 liters of water, dirty water. Okay, so for 2 grams it disinfects 455 liters. That we understood. So coming back to this formula, now N times 2 gram equals 455. So we understood 2 gram is coming from the metal spoon. That's the capacity of that metal spoon that we made the stock solution. 455 liters is the calculated value, or say the standard assumption. Okay, so I told you the assumption so that you don't wander around here and there, you don't get confused or you forget. Okay, so it is coming from the standard assumption, and N is the number of cups. Now to know the number of cups, what are we doing? So as I told you, we had this starch iodine solution. So what did we do here? We had taken the dirty water in all the 6 cups, then we put the stock solution, 1 ml here, 2 ml here, 3 ml here, 4, 5 and 6. Now after certain time, like half an hour or 45 minutes, we are putting the starch iodine solution. Okay, like 3 drops here, 3 drops, 3 drops everywhere. Now in the first drop I have put the 3 drops of the iodine solution, nothing happened. Second I put, nothing happened. But in third glass I have put the starch solution. Now in this glass, let's suppose there is change of color. Let me show you where is the, okay, let's suppose this has turned into blue color. Okay, now how is this turning into blue color? See, I'll tell you. What are we doing here? We're trying to disinfect the water. Disinfect means we're trying to kill the germs and organisms present in the water, and to kill the germs and organisms we used chlorine. So chlorine goes inside the water, it combines with the water and it forms hypochlorous acid and all. Okay, so just basically remember chlorine ions will be there. These chlorine ions will destroy the organisms. That I will anyways tell you in the further of the video. So let's suppose in this we had 200 ml of dirty water. Now the amount I have poured only 1 ml of this stock solution. That 1 ml was not enough to kill the organisms, because after the killing of the organisms there should be some amount of chloride ions or hypochlorous molecules should be there in order to react with the starch solution, and after reacting with that free chlorine ions with this starch solution, it gives the blue color. So here, as I put only 1 ml, it was not enough to kill the organisms. Okay, so there were no free chloride ions. Here also there was not enough chloride ions to give the color. But here, as soon as there were 3 ml of stock solution here, so after combining with all the organisms and other nitrates and ammonia, whatever it is there in the water, after combining with everything, the chlorine, some amount of chlorine will be left, which will react to the iodine solution and it will impart the blue color. So here we understood. So by this way we will understand, okay, so for the amount of disinfection, the amount of chlorine required was there. Apart from that, even few extra chlorine ions are there, which is giving the color. So here we understood that disinfection has happened. So further, as you go like this, don't you think here also you will get color, here also you will get, because only 3 ml you are getting the color. In 4 ml obviously you will get color, 5 also you will get color, this also you will get color. So after this, all these are heavily disinfected. Okay, so yeah, we understood. So in the third cup I am getting the blue color. So whichever cup I will get the blue color, I will take that as N. So here the N is 3. Okay, so 3 into 2 gram is required for disinfection of the 455 liters of water. Okay, so this is how it is calculated. Now let me tell you how the disinfection works. Okay, like in molecular detail. Come here. So the molecular reaction of the bleaching powder. So bleaching powder, the chemical formula of bleaching powder is Ca bracket OCl2, okay, calcium oxychloride. So this calcium oxychloride has good amount of chlorine. Okay, this is the short form of the bleaching powder. Actually bleaching powder formula is little bigger. Okay, so inside this there is chlorine. Okay, let me annotate. So this is my chlorine, and this chlorine is combining with water. Okay, after combination it is forming something called as HOCl, that is hypochlorous acid, and it is forming HCl. This is the main savior for the villagers. This HOCl in low pH, like in acidic condition, it remains as HOCl, and in high pH it dissociates into OCl minus and H plus. Now this HOCl or OCl both, like this is the most dominant one. What does it do? First is it disrupts the bacterial membrane. Okay, it disrupts the bacterial membrane, then it disrupts the metabolic pathway of the bacteria, and it degenerates the enzymes which are important for the survival of the bacteria. So these are some ways by which the HOCl, okay, it is killing the organisms, and by killing the organisms it is saving the villagers from diarrhea. Now what are the organisms that can cause diarrhea? Like all the Enterobacteria, E. coli, Salmonella, Shigella. Okay, so these are the Vibrio cholera. So these are the few organisms that can be controlled with the chlorination. Okay, then in the water, apart from just the bacteria, there are also other elements like ammonia and calcium. Okay, so there are many things, but we'll just remember that chlorine also combine with the ammonia in the water, and it forms the NH2Cl and water. So this compound which is formed, this is called as the residual disinfection, or this will prevent the microbial growth. So this is, as I told, after combining of the chlorine with all the organisms and all the other elements, whatever the free chlorine is there, that will again combine with the ammonia, or it will be there inside the water to prevent further any infection, like any decontamination of the water. Okay, so this was the working mechanism of the bleaching powder. Now we will go into the actual interesting part, that is the calculation part. Now how do we calculate the, like, how much amount of that is called as the chlorine demand. Okay, how much amount of chlorine you need to disinfect this much amount of water. Now it can be 1000 ml, 2000 ml, 4000, whatever the ml or the volume of water it is there, how much do you need the amount of chlorine. Okay, so Yeah, so we understood this thing. 2 gram is disinfecting 455 liters of water. Okay, now as generally in every village the well will be in like cylindrical form. Okay, so the basic geometry of the well is cylinder. Now we have to disinfect this well. To disinfect this well, we need to know how much amount of water is present. Now how will we calculate how much amount of water is present? That is basic maths again. So well is a cylinder, and to know the volume of the cylinder, what do? We just take the volume. So volume is nothing but pi r square into h. So for cylinder again, so this is the radius is d by 2, d is the diameter, this is the total height of the cylinder, I mean the well, and this is the height until what the water is present, the dirty water. So for cylinder, pi r square h, r is nothing but d by 2. So at the end you will get this kind of formula. So pi d square by 4 times h is the this height, the amount until where the water is present. Okay, not the this height. So for example, let's say the height of this geometry is 12 meter, diameter is 10 meter. So how will we calculate the volume? Volume is pi r square. What is r? R is d by 2. D by 2 means 10 times, like 10 into 10 by 2 square is 4, and height is 12. So you just calculate, you will get 300 pi. And now after you get the volume, 300 pi meter square is the volume of the this geometry or the well. Now for 1 meter cube, we know that it can contain 1000 liters of water for 1 meter cube. 1 meter cube means you take a box of 1 meter length, 1 meter width, and 1 meter in depth or height. Okay, so one box of 1 meter. Okay, so that contains 1000 liter of water. Now our question is, if 1 meter cube contains 1000 liter of water, how much liter of water can 300 pi meter cube contain? Okay, so for 1 meter cube it is 1000 liter. For 300 pi meter cube we calculate, and it is around 9,42000. How much it is? 1 tens, 100,000, and a lakh. 9,42,000 liters of water it can contain. Okay, so the height is 12 meter, diameter is 10. Okay, so this much with these dimensions we get this much amount of water. Now if I have to disinfect this much amount of water, how much of chlorine will I need? Now what will I do? I will again do the Horrocks method. In that I will prepare the stock solution. I will take the water from the well and I will put the stock solution 1 ml, 2 ml, all this. Okay, and then I'll put the dropper, and let's suppose I have got the n the blue coloration in the third cup. Okay, so n is equals to what? 3. So if it is third cup, then I'll just use that formula ki n times 2 gram equals to 455 liters. 2 gram is here nothing but the metal spoon's capacity. 2 gram we had used to make this stock solution. So n is 3. 3 times 2 gram giving me 455 liters of disinfected water. Okay, so that is 6 gram. 6 gram is required in this case. Why it is? Okay, so I think there is some amount of noise happening from the background. I'm so sorry about that, but we'll continue with the video. Okay, because I don't want to pause it now and then it will take long time. So we have calculated the geometry of the cylinder or the well, and we have found that this well contains 9,42,000 liters of water. Now as we have calculated from the Horrocks method, that this well needs like the demand of the chlorine for 455 liters of water, it requires 6 gram. How? Because it was the blue coloration was in the third white cup. So 3 times 2 gram is giving me this much, 6 gram. 6 gram is required to disinfect 455 liters of water. So for 9,42,000 liters of water, how much amount of bleaching powder is needed? So if you calculate, if you cross multiply and calculate, you will get around 12.4 kg of chlorine is required to pour in that well and to disinfect the entire water. Okay, so this was the example. Now the shape of the well can be changed into somewhat like rectangular well can also be there sometime. Okay, So even for that, it is the same method. You just calculate the dimension, the volume of the the volume of the geometry. If it is cylinder, you put the cylinder formula pi r square h, or if it is rectangular, L into breadth into height. Okay, so you just take the volume, and then you just calculate if 1 meter cube requires 1000 liters, then this much volume will contain how much. So around this much, and then you just check by the Horrocks method that which cup is getting the blue coloration. If it is first cup, then n is equals to 1. If it is second cup, then n equals 2. Third cup is 3. Fourth cup is 4. Okay, so that amount of chlorine is needed to disinfect 455 liters of water. So this much volume will need how much? So that is the basic question. Okay, so let's suppose this is how we calculated, and let's suppose n equals to means the second cup has undergone the blue discoloration, and the dimensions of this geometry is a length, breadth and height. Let's suppose it is 1 meter. So 1 meter cube is nothing but 1000 liters of water. So just so as I have calculated here, so for 455 liters of water, n equals 2, so 4 gram of chlorine is required. So for 1000 ml of water, how much it will require? So around 8.79 grams. Okay, so that was the basic geometrical calculation. Okay, nothing so complex here. Now this is this is for my friends who are studying in my class. So we have this exercise given in our record, community medicine record. In what exercise, I think there are around four questions. Hopefully, if I did not skip any questions, and there are certain assignment questions, right? So in that 4 questions, the first question they are giving some story, and then he's telling the cylinder is the well is cylindrical in shape. His height is 12 and diameter is 10, and this color change was seen in second cup. So you just first calculate the volume of the cylinder. You will get pi r square h, and then you will get some 300 pi meter square. Okay, and then you just convert it into liters. So 3 pi into 10 power 5 liters. Now as he has told, the change in color was seen in second cup. So n times 2 gram gives me 455 liters of disinfected water. So n is here 2, so that will be nothing but the 4 grams. So 4 gram is required to disinfect 455 liters of water. So 3 pi times 10 raised to 5 will give how much? So you just calculate, and you will get around 8.3 kg. Okay, so and as you keep practice 1 or 2 questions, and then there will be a good flow of calculation. So at the end you will be well versed or thorough with the calculation, that you will not require this amount of calculation, or this was just for the explanation, like point by point step by step calculation. This much amount of calculation is not required. Okay, you just practice 1 or 2 questions, and then you will be calculating in much faster way. So in fourth question in our record, volume is 1000 liter, it is given in the question, and he has directly given the demand is 2 gram. So for 455 liters we need 2 grams. So for 1000 liters, how much? 1000 by 455 into 2 gives me 4.4 gram. Okay, so this is the let me just zoom out. This is the entire workflow. Okay, yeah. So we understood the scenario of the village. Okay, so this is the entire notes. You can just pause and check, okay, how it has done, and then practice 1 or 2 questions. You will be done with this concept. Okay, and yes, that was all about the Horrocks method, how the bleaching powder demand is calculated. Okay, so I'll share the notes, and these are other few videos which you will be interested in watching. So yeah, bye.